top, shall we?
The average.
We see the average first. 81. No longer do you have to add a bunch of things up and divide by blah, blah, blah. Just put them in your TI, run one bar stats, average comes out. Yay! That's awesome. It's going to save you a lot of time over larger data sets. Good. Very, very good. Just like Excel does.
So that's the sum of all the x's?
This is the sum of all the test scores.
So then it's squared.
You can pretty much always ignore these next two because they're remnants from the 80s. In the 80s, those were important for many reasons, but they're not as important anymore. So if you add all the test scores up, you get 405. If you square all the test scores and then add them up, you get 32,815 square points. I don't know why you would need to know that. You don't need to know that in here. So you can ignore those two lines right there.
And is that out of 100? Because I don't think that's what.
Well, that's out of 100 squared, wouldn't it be? Yeah, kind of unfortunate. Who's that? Do you recognize him?
Yeah.
You recognize that number, 1.58? That's your sample standard deviation. That's your sample standard deviation. Yay! So that crazy annoying calculation you just did, you don't have to do anymore. It'll do it for you.
Is that the average deviation?
Which one? 100?
Yeah.
Now the 100, very good question, Randall. The 100, I'm going to mention briefly here and come back to on whenever I see you then, Wednesday. This is lowercase sigma. That's big sigma. This is lowercase sigma. That's the population standard deviation. So Corey, remember when you asked me, why are we dividing by 5? Why don't we divide by 4? If you were to divide that by 5, that means that would be your entire population of values. And that's the number you would get. But we never have our entire population of values. This is a fiction I wish the TI would stop showing you. You see what I'm getting at, friends? It becomes real when we deal with probability distributions, and that's in about 5 weeks, because then we actually do have everything that can happen. But when you have a sample, this shouldn't exist. This shouldn't exist. And what I love about the TI is, when we actually deal with the probability distributions later, this goes away. Because it knows this is the only one that matters. It's totally awesome. So for right now, if you need a kind of a way of keeping straight what's important, keep this in your mind right now. This. You want to know that? Yes. And you want to know that. Those are the two from this first screen that are very, very important. Notice how down here it tells you n equals 5. You probably knew that. There were 5 things you put in. Little n equals 5. You can ignore that, and you can ignore these two for the time being. Really, the takeaway right now is that's all you need. If I could get into your calculator and make it only give you what you need, I would. I just don't know how to do that. I wish I had the computer know how to get in there. I know you can, but I just don't know how to do it.
I like it.
Now, there's more. See that little arrow right there? Scroll down. Scroll down.
So how do we...
There's more. Yeah! Your median's in there. 81. No more putting things in order, crossing them off.
Q3.
Q3 and Q1 are called the quartiles. If you've never seen those before or heard of them before, I got a whole day planned around them in about a week. I want to get back into those. But they're different enough from the measure of variation that I'd rather kind of ignore them right now. We'll come back to them, I promise. Min and max, you know what those are. No, hopefully. Small margin. What doesn't it give you? Doesn't give you your mode. But the mode you could probably figure out without having a calculator tell you what it is anyway. You can also program it if you wanted it to, but you can probably just identify it from the data. Naveed, go!
What's the min and max?
Smallest data point in the set.
Oh.
Largest data point. So his smallest test score was a 79. His largest test score was an 83.
Oh, okay.
It's just, and again, you're kind of like, why would they tell me that? There's 5 data points. If you've got like hundreds of data points, that might be a good feature to have.
So what about the 100?
What about the 100?
So wouldn't 100 be the highest?
No, that he got. This is Ernie, not Bert.
We just did L1.
We just did L1. We didn't do Bert yet.
Okay.
Right? All we're doing right now is revisiting Ernie. And it takes us, what did that take us? About 15 seconds versus 25 minutes. That's a good thing. That's a good thing. Why did I make you sit through this computation of standard deviation? So you know what the 1.58 means. What does it mean? I'm not picking on Alicia again. What does the 1.58 mean?
How many points on average that he deviates from the average?
I said I wasn't going to pick on you again, Alicia. That was beautiful, though. I want to pick on somebody else. Aaron, go. That's okay.
I thought you said
No, I'm not going to pick on you again. Aaron, go.
It's the average points from average, right?
Give me a little bit more. Use the 1.58 in your.
So 1.58 is the average distance from the average.
From what from the average?
Distance.
Of what to what? You see, you're giving me something to average. What are we taking distance from?
I guess I'm lost.
No, you're not lost. You're 95% of the way there.
Okay.
What are we measuring the distance of when we measure standard deviation?
data points.
The data points to the average of the data set. So that's the only thing you're missing. You got everything else. 1.58 is the average distance of the data points from the average. So if you look at the average distance, they're all different, right? Generally, you've got smaller distances and you've got larger distances. But the average distance of the data points to the average is about 1.58. That's the only thing. Everything else is perfect, brother. Is that fair? Is that fair? That's why it's useful, because we pick up Corey's idea of individual distances between, we tie in Lily's use of the average, and we get it all in one place. I'm not saying the n-1 makes sense, I'm not saying that. But I'm saying that this gives us a really nice, commonly used measure. Let's do Bert's. Let's do Bert's. Shall we? Yes. Maybe. Yes.
What's Q1 and Q3?
Q1 and Q, if you don't mind giving me about a week on those, David,
sure.
they're a measure of what's called relative position. I love them, personally. How many of you guys ever taken your kids or been at the doctor's office when they tell you you're in the 80th percentile for something? That's Q1 and Q3 are like that. You get used to it soon. Yes, we have those, right? I'm going to use Max as an example next week to talk about that, because it's a very, very fun measure when used properly. It's also infuriating when they use it improperly. So we'll talk about them, I promise. You already know one of them, believe it or not. The median is a percentile, believe it or not. Yeah, it's the 50th percentile. You don't realize, you might not realize that yet, but some of you might if you've had stat classes before. Don't worry about that though. I promise we'll get back into it. This gives you more than you need right now. Let's do Bert. So press your stat button again. Let's restart this.